Good evening, sir. Good evening, all.
Good evening, sir.
Good evening to everybody.
Good evening, sir.
So we have today two presentation schedule. Like first is from Abhinav, Naveen Sinha and their group. Okay. Don't know if they have submitted. Like we had given them, sir. Just let me brief you about the status so far. So we had a project, live project scheduled for this PGCSM course. So for that we have done one a mid evaluation also. Around 25 marks was associated for that, and for that result also we have declared. Correct. So last time I think one group was not present in that. I think this Abhinav, Naveen Sinha, they have not presented their progress so far. So let's see today what they are doing. So today it's total 70 marks we will allocate today. So sir, I have already told you it's like 50 marks for technical content and 25 marks for the presentation. So yeah, so accordingly we'll do. And instructions also we have given. We have asked them to submit uh, project report by, earlier it was I think last month. Then we have again extended because a few people had problem with their health condition and all. So we have allowed till 3rd, and I don't think we have received everyone's presentation. So Abhijit, can you update like how many progress report this project report you have got? I think we have received only for one.
Yes, sir.
That is from Meena
Few
and
project reports we have
Rajnikant.
received.
Huh?
Yes, sir. Yes,
Yeah,
sir.
we
We
have
have
received
received
only
two
from
project
one.
reports.
Yeah, we have received only from the one. So actually,
Yes, sir.
yeah. Then
I'm
so
just sharing both of the project reports that we have received. Just give me a minute.
yeah, please share it. So this is one also. This is Abhishek Kumar, Rajnikant, and Keshav Gupta. Okay, these two. So we have not received this project report so far. The uses of autonomous quadcopter, no? Which is right now it is scheduled. So anyone is there from this group?
And one more is from Mubin Akhtar, sir. The group members are Rajnikant, Meena, and Sajid Kam.
Yeah, Rajni, Keshav, inka to we have received actually, है ना? We have received their report. I'm just going to share that report with both of you, sir. Can you please share that report with Dr. Sikdar and Dr. Ravishankar right away?
Sir, sure, I will.
Yeah, please share them and let's see how they present. So let's take their group first because I don't see the other group is right now they are here. So who is going to present in that group?
So me,
Rajnikant.
Abhishek and Rajnikant, sir, we will both
Abhishek.
presented.
So you know the guidelines. We have last time told you like what are the modality for this. Actually, you need to uh, highlight the main thing is this is in line with the project report which we have told you to prepare. Correct? It should have the motivation. It should have the research gap. It should have the research methodology. What you are going to use. You should also put some sort of scientific contribution also. Right?
Yes.
So that already we have shared you. In line with that only, I believe you may have prepared your presentation. And before starting, please highlight the contribution of each member of that group. Okay, that is again needed in the presentation. Also, you can highlight because that will again that contribution will highlight in your marks also. Correct.
Okay, sir.
So, any suggestion from Abhishankar and Dr. Sikdar before starting the presentation?
Let them start, Himanshu. We'll go through presentation and then we'll give our comment.
Correct.
Yeah, I think that's the best way. That's the best way.
Yeah. So, I mean, like before starting, if you have some instruction for them, so that we can follow. That's it. So you can start. We start the second group.
Okay, sir. Okay. Abhishek will start, then I will continue.
I'll just turn off my camera. Yeah.
Hello, Abhishek. Can you share your screen? Yes, yes, yes. Yes, yes. It's okay. It's visible.
Is it visible?
Yes, yes, visible.
Okay. So good evening, sirs. Our project title is Advanced Machine Learning Approach for Smart Battery Management System in Electrical Vehicle. Our group members are Abhishek Kumar, Rajnikant, and Kesav Gupta. So, see, in the electrical vehicle are gaining popularity because of the rising worries about the global warming, the release of greenhouse gases, and the depletion of the fossil resources. So electrical vehicles are among the most promising solution in
Yeah,
decreasing.
1 minute. Yeah, sorry. So Kesav is here right now?
No, sir.
Huh?
No, sir, but his contribution is also zero.
So, okay, his contribution is also zero, or he is not here also. Huh?
No, sir.
So Keshav Gupta, correct na?
Yes, sir.
Okay. ठीक है. Okay, you can continue.
Yeah. So as I told you that the electrical vehicles are gaining popularity because of rising worries of global warming, the release of greenhouse gases, and the depletion of the fossil resources. And the electrical vehicle are among the most promising solution in decreasing the CO2 emission and the global environmental concern. But the storage system technology still slow down the development of the electrical vehicle. The battery pack of the electrical vehicle account for about 40 to 50% of its total cost, and this cost is largest single factor in the price differentiable between electrical vehicle and the internal combustion vehicle. So so the energy storage system technology is still the logjam for the electrical vehicle industry, and the storage system technology still slow down the development of the electrical vehicle. So the lithium ion batteries have drawn significant attention in the EV sector due to their high energy density, long lifespan, nominal voltage, power density, and low cost feature. Many high power applications such as electrical vehicles, smart grid uses lithium ion battery pack with built-in battery management system. So a vital part of the electrical vehicle is the battery management system, which correctly detect the state of the battery and make sure that the vehicle stay in operation and accurately estimate the state of charge of the lithium ion battery. So as the result, the significant design is placed on the battery management system software so that it can estimate the state of charge accurately and also the state of health. So let us quickly review what is the lithium ion battery. So the numerous energy storage technology, including you can say the lead acid, nickel metal hydride, and the lithium ion battery have widely employed in EVs application. The lithium ion battery, despite of having high initial cost, lithium ion battery have proven an appealing option for the electrical vehicle developer due to its promising performance in automobile, cellular phone, computer applications, and substantial research and the development have been conducted to improve the lithium ion batteries performance in safety dependence and the durability. So a lithium ion battery is rechargeable battery. So this figure illustrate the lithium ion battery. The cell comprises of 5 regions: a composite negative electrode and a composite positive electrode, a separator, two electrode current collector, So this is the case of discharging and this is the case of charging. So the lithium ion move from anode to cathode while discharging, and it move in opposite direction while charging, which is shown in the figure. So the nominal voltage, power density, and the energy of lithium ion cell vary among different chemical composition of the lithium ion batteries. So the lithium ion battery cell can normally provide the voltage of 2.5 volt to 4 volt, depend upon the chemistry used. And the lithium ion battery have the highest power density and energy density among any available commercial cell today. With its great performance, it become popular for the electrical vehicle. Okay, so but meanwhile, the thermal run away is one of the concern of the lithium ion battery, which may lead to fire or explosion. But also the other features like cell balancing, pressure relief, overcharging can be also the concern of the lithium ion battery. Thus, the battery management system are needed to control the battery pack. Now the question comes, what is the battery management system and why battery management system is so important in electrical vehicle? So the battery management system is an electronic system that manage a rechargeable battery to ensure its operation safely and effectively. So BMS is designed to monitor the parameter associated with the battery pack and it's the individual cell and apply to collect the data to eliminate the safety risk and optimize the battery performance. So what is the primary function of the BMS? First is safety. So battery management system continuously monitor the parameters such as the temperature, voltage, current in and out of the pack to ensure it being operated in safe condition. Second function is performance optimization. So the lithium ion battery perform best when the state of charge is maintained between minimum and the maximum charge limit. Third one is health monitoring. So the BMS uses to collect data point such as temperature, voltage, current to estimate the state of charge and the state of health of the battery pack. The last function is communication. So the BMS is responsible for communication with other electronic control unit in the vehicle. It relies the necessary data about battery parameter to the motor controller to ensure the smooth running of the vehicle. Okay, so this figure presents the diagram of the effective BMS. So the voltage and the current measurement unit is installed to measure the voltage and the current of entire string as well as of the single cell. The temperature control unit is added to measure the temperature of the battery and the coolant. The cooling and the heating system can be controlled through this temperature unit. So the safety unit is used to avoid any physical damage of the battery pack. And the digital output of the BMS is state of power, state of health, state of charge, capacity estimation, and the thermal management. So our objective of this project is to estimate the state of charge of the lithium ion batteries. Now the question arises, what is the state of charge of battery? So the state of charge is measure of the remaining capacity in the battery compared with the maximum capacity of battery in percentage. So an accurate SOC estimation is most crucial part of the BMS design in the electrical vehicle. This is not only provide the information of useful energy, but also prevent the battery from discharging and charging condition. So there are different methods are used to estimate the SOC. First one is direct measurement. That is, this is the conventional method for first three. Open circuit voltage and electromotive force. Second is bookkeeping estimation. That is the Coulomb counting. Third one is model-based method. That is Kalman filter and adaptive Kalman filter. And the last one is machine learning algorithm. So more and more battery data and the better computational power capacity are available right now. So it leading to increase the use of data driven technology such as like learning algorithm to calculate the SOC of the battery. So in the present work, we use different machine learning algorithm to estimate the state of charge of the lithium ion battery. So before going to the methodology, numerous researchers had already applied some different
Hey,
machine
Abhishek,
learning. Yes, sir.
Abhishek,
Yes, sir.
can you go to previous slide?
Yes, sir. Yeah.
So what is drawback in above three methodology?
Sir, in the open circuit voltage, we are only using the voltage and current, and from that we draw the SOC. We are not considering the temperature and the other parameters here. They only the voltage is considering here. And in the Coulomb counting, sir, it is only the current is considering with respect to the time. We can also use the model-based method, that is the Kalman filter, but that is very complex method.
So why it is complex? Actually, that is also easy, no? This
Kalman filter,
model-based carbon filter.
yeah, that we can apply for. I don't know in the detail about the Kalman filter.
So why do you need temperature actually? So this, okay, remove third one, but first two, is it estimate is not correct? Estimate
First
of
two,
SOC in first
first,
and second, estimate
yeah,
of SOC is not correct. That's why you need fourth one and third one.
third and fourth one.
Yeah.
Yes, sir. Because the sir, actually, sir, in the first one, we limited the input parameter, and also in the second one, because sir,
That's
in
okay. Actually, you have limited it, but if you get right answer, then you don't have to go for third and fourth one. With the minimal parameter, if you are achieving your goal, then why do you need to measure more parameters actually? Because it's not free, no? You need more sensor to do it.
but sir,
You
the
need more storage devices to store it.
but the sir, temperature is the very crucial part of the battery management system. If we cannot control and measure the temperature, then it can explode the means the lithium ion fire and explosion can be happen. And this is the important factor for the SOC measurement.
So
How the
what is the unit? I mean, what is used for measurement? Actual physical, I mean, level one system that you use for measuring temperature.
in the direct measurement, we are not measuring the temperature. We are only measuring the voltage and current.
Okay, no, no, I'm just asking what is done over there basically to know the status of the battery
Yes.
about its temperature. How is it measured, the temperature?
Actually, sir, in the they actually for the research purpose, what they did that they put the battery pack in the furnace and slowly they increasing the temperature and then measure the parameters for research purpose.
I just want to know whether it's some kind of a thermocouple or some other. I mean,
No, sir, no, sir, no, sir. It's directly because I read in the paper that they have shown in the figure also that they directly put uh, the battery pack into the furnace and they slowly increase the temperature. In the different temperature, they measure the input parameters.
okay, I see. Okay.
Okay, so the numerous researcher has already applied the different machine learning method to estimate the state of charge with different input and output. So as you can see that here, few of the researcher used the deep learning neural network, multiple regression analysis, LSTM, random forest, SVR, and the backtracking search algorithm. And here the input is also changing mostly they are using the voltage, current, and temperature. Here the discharge is also considering, and in this case, average voltage, average current, temperature, and number of cells is also considering. Okay, so
what is this multiple linear regression?
what, sir?
What is this multiple linear regression? Row number 3.
Yeah, they have more than one variable input variable: voltage, current, temperature, and charging and discharging.
No, multiple linear regression. Is it
And
one model or multiple linear regression model?
it is a multiple linear regression model.
So what is
With
multiple linear regression?
It is the extension of the linear regression that we have more than one variable input variable, or you can say that the independent variable.
No,
Y
that
hat
is
is
not
equals.
correct. No, that is not correct actually.
It is actually it is the multiple linear regression is used to stimulate the linear connection between the independent and the variables and the dependent variables. It is the extension of the, you can say, the ordinary least square method. That is, it consists of more than one independent variables.
So then they had to write linear regression itself. In linear regression also you can have multiple variables. Linear regression also can have more than one variables.
Yes, sir. This is the extension only, the multiple linear regression. That is
That's
y
why
hat is equals to.
where is that extension? I want to understand this extension actually. So basically, I think they have multiple linear regression. So it may be what they have done is they just built based on some logic. They have segregated data, and then they have built something like for every subset of data, they have linear regression model. That's why they are calling it multiple linear. Just check it in literature. So usually there's something called piecewise linear regression, cluster-wise linear regression. That is multiple name of it. I think they are using some sorts of that. So linear regression also can have a number of inputs. There is no way you can stop it to have a number of inputs. That is also that's also called linear regression only.
Okay. We have also used that means the multiple linear regression means you can say the linear regression extension of the ordinary least square.
That is not multiple. You can say the multivariate linear regression.
Yeah, multivariate. Yes, sir. Yes, sir. Yeah, multivariate. Sorry.
Terminology you have to be very specific actually. So multiple
Yes, sir.
linear regression have another meaning. I know this terminology. Multivariate is another thing.
But sir, in the paper, most of the place they written like that, the multiple regression, not the multivariate.
Anyway, yeah, you just continue it.
Yeah. So the recent advancement of the artificial intelligence in the domain like computer vision and driverless car have accelerated machine learning based method to the battery status prediction and the accurate estimation of the SOC. So this figure, so here we are using the linear algorithm, that is the multivariate linear regression, ridge regression, lasso regression. For the nonlinear algorithm, we use the KNN, support vector regression, decision tree, and the random forest. And also the time series analysis, we use the ARIMA and LSTM. So so first we have to do the data collection, that is the battery specification. So in the collection of the input variable and sample was done with the lithium iron phosphate battery with the nominal voltage of 3.4 volt and the nominal capacity is 20 ampere hour. So the input is here voltage, current, and temperature, and output is state of charge. So in general, several factors influence the state of charge of lithium battery in real world operation condition, including battery parameters, the vehicle range, the road environment, and others. So, however, only the limited number of data point may be gathered and utilized. So, as the
How do you
result,
get the value of SOC? Hello.
yes, sir.
How do you get this value of SOC?
So,
You can
sir, it is yes, sir, yes, sir.
go ahead. Tell me.
Sir, in the battery management system, the digital output is state of power, state of health, state of charge, and capacity, capacity estimation, and the thermal measurement. So from there, we will get the state of charge.
So it's a inbuilt system over there, is it?
Yes, sir. Yes, sir.
And from where you have collected this data, I mean, like all these.
Rajnikant sir did that.
Okay, from his organization. Yeah?
Yes.
And
yes,
how
sir.
many data you have collected? How many number of data?
Sir, we have 5,778 data. It is yes, sir. So here so it's this is the first 5 data, that is we are used to summarize the time, current, voltage, temperature, and SOC. So total number of data is 5,778. So this is around 5,778 data was collected over a period of 1.5 hour. So next, what we did the
So
simple,
what is meaning of negative current?
what, sir?
Can you go back? What is meaning of negative current? Current is negative. What does it mean?
It is, sir, discharging, sir. Both are continuously doing discharging and charging. We collect the data. So current is fluctuating between negative to positive, sometimes negative to positive. Discharging and charging both.
Okay.
So the correlation coefficient is utilized to determine the strength of the connection between the state of charge and the other features. So when an increase in the input variable is observed with a simultaneously increase or decrease in output variable, they said to be that the correlation between the two. So from this figure, we are going to measure how strongly current, voltage, temperature, and SOC are related to each other. So here the dark square represent the strong correlation close to 1, while the lighter one represent the weaker correlation that is close to 0. This means that all this the diagonal or dark red, that is variable, is fully correlated to itself. Now the we notice is that here the correlation between the voltage and the temperature is minus 0.81, and the correlation between voltage and the current is minus 0.51. So this indicate a fair relationship between the voltage and temperature, and also the voltage and current. So here we can infer that when the voltage is increased for SOC, therefore negative tendency to spend more on current. So by visualizing this heat map, we can see that the voltage and temperature are strongly related to SOC. On the other hand, there seems to be a weaker correlation between the current and the SOC. Okay, so by looking the first plot, we can deduce that the SOC and current is inversely proportional. So the relation between SOC and current is inversely. And in this figure, the SOC and the voltage and increased trend can be observed. Okay. So, however, in the last figure, the SOC and temperature are inversely relations, which can also seen from the heat map. Now the next is we are applying the multivariant. Sorry for the error, sir. So the multivariant linear regression. So the multivariant linear regression is used to, you can say, the stimulate the linear relationship connection between the independent and the response variable. Okay, so it's the extension. So multivariant regression is the extension of the ordinary least square method. So here the R2 of the linear regression is 0.69 and the RMS of root mean square error of the linear regression is 0.45. So when we interpreting this result of multivariant linear regression, it shows that the model is not always correct for each data point maybe deviate somewhat from the model projected conclusion, and this is the residual value, which is the difference between the actual and the projected outcome. And this graph shows the predicted state of charge versus the actual state of charge. So actually the ordinary least square treat all the variable equally, that means unbiased, having the lowest bias and the highest variance. So the regularization is one of the method widely used to make model more generalized. So we can say that.
So Abhishek,
Yes, sir.
so where is your Q square value?
So that I will explain in the end, sir. What is the problem
Can you
we are
go
facing?
back? Actually, I want to see a standard deviation of SOC. Can you go back? So yeah, just wait here. So you have mean is 31. You are able to predict 31 plus minus 1 standard deviation. So your RMS is around 0.5 only, correct?
Yes, sir.
It seems linear regression is doing good. So what is problem actually?
Overfitting, sir. We are trying to do the regularization to avoid the overfitting of data.
Where is overfitting actually? Can you show me overfitting?
We did the analysis of outlier and means here we can.
No, that's why I was
This is
asking you to give me Q2 score. No, that's why.
Sir,
So how?
we tried to find the Q2, but we faced a lot of issues. That's why I put that in the end.
Can you just outline how you have built model?
Uh, this the multivariant regression model.
Yeah. Just from getting the data, you have got the data. And after that, what you have done?
After first we got the data, and then we check the is there any null value or not, and then so there is no null values. Then we see the correlation between the features. So we have so actually we have here the time, current, voltage, temperature, and SOC. So for the this method, we eliminated the time. We only find out the trend. So our input is current, voltage, and temperature. Output is SOC. Then we use the uh, standardize the means the scaling. We did the scaling of the variable, and then we use the multivariant regression model by using the scikit-learn.
So you have
And
splitted your data in train or test?
yes, sir.
70, 30 something.
70, 30, sir. Yes.
Okay, so 30% data is how much?
30
You
is
have
around
5,000, na?
2000, around 2000.
So you have
1900.
2,000 data to test it.
Yes, sir.
Okay. So what happened with your Q score? What issue you were getting it?
So right now, explain that, sir. Okay, sir. Wait a minute. I will explain that. What is the problem? So actually the Q square that is the
No,
predicted.
do one thing. You finish it, then you show us code actually.
Yeah. Okay, sir.
Yeah, okay.
But this itself is performing good only.
But he's saying that Q2 is the Q2 had issue actually. So R2 we cannot infer anything. R2 seems
sir.
to be okay actually, but he's
Yeah.
saying Q2 had issue. So that's why we
Issue
want to understand actually.
issue means
Anyway,
we are unable. Yes, sir.
you complete it. Yes, what you have done, you
Yeah,
get
you
this.
go ahead and then tell. Okay.
Yeah.
Okay, so then we use the regularization methods. The first one is ridge regression. So ridge regression is the model tuning technique that uses to analyze the data. So this technique generally apply the L2 regularization. So here in this case, the R2 value is 0.69 and the RMS value is 0.55. So if we see from this data that is 0.69, this is almost same, and RMS value is almost same that the ridge regression. So next what we did that we used the lasso regression. So the lasso stand for the least absolute shrinkage and the selection operator. So it is also a regularization method. So it is preferred for regression approach to provide more precise forecast. So here the shrinkage is used in this model. So the shrinkage refers to the process by which the data value are compressed towards the center point, that is known as mean. So here, if you see that here also the value is almost same, that is same as the multivariate ridge and the lasso. So the main problem of the lasso is that when we have the correlated variable, it retain only one variable and set other correlation variable is zero. So that is the possible lead to some loss of the information resulting in the lower accuracy of the model. So that's why we are moving to the non-linear algorithm. So the first one is that is the KNN regression. So actually the KNN regression is a non-parametric technique that approximate the connection between the independent variable and continuous outcome by averaging the data in the same neighborhood. So the KNN algorithm uses the feature similarity to predict the value of new data point. And this means that the new point is assigned a value based upon how closely it reassembles the point in the training set. So the KNN is better than linear regression when the data have high signal to noise ratio. So here the R2 value is 0.977 and root mean square error is 0.27. So if we compare from the linear regression, so the RMS value is much lower than the multivariant ridge and the lasso regression. So so next, Mr. Rajnikant sir will explain the further process.
Hello, good evening, all of you. Sir, after trying linear regression, Ridge, Lasso, and KNN, we tried for SVR model. And SVR is one among the most popular and extensive used algorithm in machine learning. This model takes account of non-linearity in the data and generate an accurate prediction model. SVR is a method of predicting discrete variables using supervised machine learning. And SVR is like SVM tries to find out the best fit line, but in SVR, best fit line is in the form of hyperplane. So hyperplane is used to separate two classes of data. So different kernels are used for nonlinear functions. The type of kernels are linear, polynomial, RBF, sigmoid, and Gaussian kernel. So we tried all of them, and the best RMS value for our case was radial basic function, that is RBF. So in this case, we just try to map the data in the input space X to a feature space F by using a non-linear function, a mapping function phi. That is our kernel. So go to the next slide. Then we tried, after doing this, we tried decision tree regression. And in decision tree, what is a non-parametric machine learning model used for classification and regression model both, and required less data. The advantage of decision tree is it requires less data pre-processing and no need to scale the data. So for measuring randomness for regression problem, we need to calculate the mean square error. So we same way we calculate the RMS value in decision tree also, and after that we tried for random forest, because the disadvantage of decision tree is if the data is very small, or even a small change in the data set can result a significantly different tree structure that can create a significantly different tree structure. So we tried for random forest regression. So the working principle of random forest is basically we won't rely on a single decision tree, but we create a multiple trees, decision trees, that are called forests. So we will go to each decision tree and ask the question from every decision tree. Then it will collect all answers and it will provide one consolidated answer. So random forest is an example of ensemble learning. So in our case, the lowest RMS value was also for random forest itself. So these are the comparison chart of all the algorithm with RMS values. So in our case, lowest RMS values was for random forest itself. So as per the last suggestion, we tried to eliminate the outliers. So we use the technique minimum covariance determinant, and for that, after the outlier detection, we tried the model once again, and once again we found that the lowest RMS value was for our random forest itself.
So what is this minimum covariance determinant? What does it do? How it is helping in outlier detection?
Actually, sir, it is the method for estimating the mean and the covariance matrix in a way that it tries to minimize the influence of the outlier.
Correct. Then how it is helping you to find outlier? So basically you have used some methodology to remove outlier and rebuild the model, correct?
Yes, sir.
So I want to just understand this, how this outlier detection technique works. Minimum covariance determinant.
Sir, we use box plot method.
That
Sir, we use simple box plot method also. We use the simple method also, but we find this technique from the literature, so we use this.
So basically, whenever you use any algorithm, so you have to try to understand it. Otherwise, what it is giving you, you cannot judge it. So you have to understand exactly how things are working and what it is returning it to you. So basically, minimum, I think what it is doing is this minimum covariance is in Mahanaboli's distance calculation actually. So basically, it compute robust, something called robust covariance based on this, what is called minimum covariance determinant. So iteratively, it will go and select the different sets of data and get the covariance. You have to give, I think you have to pass something like how much outlier you can expect in your data set. That information also you have to pass to get this minimum covariance determinant. Correct. Once you estimate what is your covariance matrix, because these are the metrics influenced by outlier. So that's why something called robust outlier determination, where you use something called robust covariance, and this is the minimum covariance determination is the one way to do it. Okay.
Okay, sir.
So something called Mahanaboli distance, and then that has to be less than equal to chi-square distribution based on your degree of freedom. You get the threshold. Anything coming away from this, it's considered as an outlier actually.
Yes, sir. I read about the Marapolis, but I forget.
What is the what is the physical meaning that why this RMSE value is lowest for random forest model? Any reason? Why not for other model?
Sir, generally, whenever we use different algorithm, so we saw that the random forest works better.
Why here this one RMSE value is the lowest? Or why not others? I mean, that's random forest is any physical meaning that you can provide.
And how you can use this RMSE value, by the way? So what is significance of this RMSE values? How you are going to judge a model based on this RMSE values? I think you also report what is Q is square. Otherwise it will suspicious actually.
So,
Yes, sir.
so what you have done, what I believe you have built a predictive model, and you have tried all different machine learning algorithm. This is the part of your building the random forest model, which finally you are, which is your report is saying, correct? That you will go
Yeah.
with the random forest model and it gives you best RMSE, correct? So all those
Yes,
other
sir.
exercises which you have presented here, these are the part of the modeling, because any model you will build, you try to build, try to see like which model fits best, and how to remove outliers and those sort of things. So anything else, after this predictive model, or this
Yes,
is
sir.
what, like,
Sir, so okay. Sir, explain it.
yeah.
Rajni, sir.
Yes, yes, sir. Then, sir, since it was a time series data, so we use time series analysis also. So the first issue with us was the data was not equally distributed. So we resampled it with the interval of 5 seconds, and then we took the average of the corresponding column values. Then this is the visualization part for current versus time and the voltage versus time. And this is the visualization part of temperature versus time and SOC versus time. And then we tried the ARIMA model also.
No, Rajnikant, you have to be very clear actually. So what you are doing here, you are now building a time series model, correct?
Okay, sir.
So you dropped other feature like temperature, other thing, or how did you build this model actually?
Sir, auto ARIMA is generally a univariate method. So in this case, in ARIMA, we drop the current temperature and voltage. We only taken the time and the
SOC and time.
SOC. And in the next method, that is the
So,
LSTM, we are
So
considering the
Arima is not a univariate method actually. It is not like that. So basically, you have to incorporate that other input as an exogenous input. Correct.
actual.
So you have something SOC. You have time stamp associated with each SOC. Then you have sets of exogenous input, and then some random input actually, what is called EX actually. So basically, you have two part actually. One is deterministic sorts of input. Another is random sorts of input actually. That okay. So what you have done first actually? Have you? If I can see, there is a trend between SOC and time. Can you go to previous plot? So SOC and where is SOC? SOC and time.
Last
Na?
one, sir. Last one.
So this is not stationary actually. This is not a stationary signal.
So we have checked the stationarity, sir.
But
SOC is the stationary.
this is not look stationary unless you chunk up to like uh, up to 0033. Before that, it is decreasing actually.
Actually, so the temperature and the voltage is not stationary, and the current and the SOC is stationary. We have checked that.
No, the plot number first.
First one is
Below,
not. It is not.
below one is SOC versus time, correct?
Yes, sir.
Yes, sir. Yes, sir.
So this is not stationary, no? See, it is dropping it from 85 to somewhere 20, and then it
Yes.
seems to be stationary actually.
Yes, sir. Yes.
So actually, sir, we then use the stationary method to make this is stationary. That this is.
So how you have made it stationary actually? Which method you have used?
The first difference. Okay, wait. Wait. We minus with the previous value of SOC. I don't remember the methods or that.
Okay, go to next slide. Don't use any method which you don't understand actually. Otherwise, what it will reflect, you also don't know.
Sir, we tried Dicky Fuller test, but we didn't applied it.
Actually, sir, we did the vector auto regression integration moving average. In that case, we can consider all the input variable and associate. But in that case, we are facing some issue. We will not getting the proper graphs.
So vector autoregressive is when you have multiple output. It's not about the multiple input actually. So if you want to consider this multiple input, so you have to give something called exogenous input, and then all your these three things will go there. But you can see there are trend actually. So whenever you
Yes.
go for any time series modeling, you have to model each and every component of time series. So any time series data can be decomposed into trend, seasonality, and then stochastic component. Trend you can fit it first, then you fit seasonality, and then what it calls the stochastic thing.
Yes.
Okay, which comes with your exogenous, what you call EK actually. What ARMA and ARIMA, whatever you are talking now,
Yes.
that is nothing but your stochastic model. Anyway, you have done something okay.
Sir, we created 4 model for ARIMA. One is 112, 111, 000, and 010. And AIC BIC value was minimum in maximum in ARIMA 00 only. And for the rest
So
of
what is
them,
AIC? What is AIC?
archaic information criteria, sir.
So why do you do AIC?
So it automatically shows in the summary itself.
Okay. So basically, when you have to compare two model, you have to see actually AIC values.
Yes, sir. So it automatically shows the AIC and VIC value in summary itself.
See, that's why I told you now, whatever automatically is giving, that not mean that you have to understand and then see exactly what is meaning of all this and how to use all this thing. Okay, so you have used this LSTM also.
Yes, sir. Yes, sir. We use LSTM also. So the optimizer we used Adam, and the number of epochs we used 20.
But sir, again, actually, we are not again finding some difficulties in the plotting the forecast value in this case also the LSTM. Why? Because there the means if you see the data, these are the repeated values, all of this. So we are getting none values. I've checked in many cases. They are saying that if there is a duplication in the values, the previous value, it will automatically show the none.
So basically, there is instances where the things are inputs are not changing and outputs are not. But like it may be that switch off condition or something.
Hmm.
So anyway, you have this LSTM. Anything else you have to show us?
No,
So,
sir.
sir, this one, the last I want to discuss that the predictive R square that is equals to 1 minus predictive residual summation divided by sum of square total. So what we have faced, sir, in this case, we are getting error for when we are finding the H hat. This HJJ, which is equals to the inverse of this. So here we use the pseudo inverse, but again we are getting different something like minus 587.84. So, but that's why we are getting some difficulty of finding the H hat value in this case.
So
That is the Q2.
that's why I was asking you to put it Q square value. So it seems like it is not doing good job.
No, sir,
You're-
we are getting error in that finding H value because the H value is not correct.
So why not you use just R square thing? Why you have wrote your own code actually?
No, there is no inbuilt function for calculating the predictive R square. Or you can
There
repeat
is
it.
nothing called predictive R square actually. So same thing, whatever R square you are using, you have to use actually test data. With the test data, you have to
Yes.
use your model. Then you have to use test data to predict it and use same formula. You don't have to write all this thing. Just R square formula is there now, R square. Just import that. The way you are computing R square.
Yes, sir.
So R square for the training sets of data. And then something called predictive R square, that is with the test data actually. Same way you have to do it.
Yes.
So don't have to calculate all this transpose and all.
Okay.
This transpose and all, if you don't know how to construct the X matrix, all things will be, you will not
Yes.
get correct answer actually.
Okay. So that's all, sir, on our side.
So what is, by the way, this X matrix? Do you know how to construct this X matrix?
X is so this is X is sir the that we are using for the training data, that input variable.
I think you have done all the, you don't have to do all this actually. You just use your inbuilt function. Only thing is you have to just change the data. Instead of training data, you have to use test data. But same
Okay.
time, R is Q square can be minus infinity to 1. Okay.
Okay, sir.
Minus infinity means model does not have any predictive capability.
Okay.
Okay. But
Okay.
R square can be 0 to 1.
Mm.
Okay.
Yes, sir.
Sir, you have any question for him?
Can you go back to the slides? Okay. Yeah, go back. further again. Okay, one more before last one. Okay, multiple linear regression. Okay, just hold on. One more back, one more towards back side. Okay. Just so most of your data in temperature, okay,
Yes.
they are in the form of clusters. I can see here. You know, you see, in some places, okay, they are just in the lower temperature side. Okay, there is no cluster in this side. There is more cluster here. Okay, and here it is scattered. What is the physical reason?
Actually, sir, this data is collected when we are doing the charging and discharging. So at some time we are charging so at that case, that time, because of that charging, discharging, this is changing. It is not, some places is cluster and some it is not. Because sir, actually, initially the battery has 100% SOC. And then we slowly using the loading unloading phase and varying the temperature and voltage, and that's why it is in few places it is cluster and in the few places it is not.
Okay. And the normal temperature is around 27 degrees centigrade. Is it?
It is varying, sir. Actually, if you see the graph, actually we started from 24 and up to it goes 30 for almost 2 hours.
Okay. So it's almost like atmospheric temperature.
Yes, sir.
Yes, sir. Yes, sir.
Okay. Okay. Can you go back one further? Okay. And here, yeah, you see this current as if this SOC. It's a very it's a it is almost spreaded in particular region. You see that although you have drawn one straight line to fit it, okay, SOC versus current, but you see all these things are there scattered over here, just like uh, it's some kind of a lump thing that it has come up. Okay.
Yes, sir. In this.
Yeah. But compared to that, at least for voltage case, okay, fine, it's better. But why is it for the current? It's something like that.
Actually, sir, we cannot increase the current. We only vary the current from minus 0.15 to 0.25 ampere. That's why in this reason we have more elements in that time, means from you can say 0 to 0.20 current, we are getting more data. We're changing the current.
Okay. And what about? I mean, if you just increase the range, what happens? You don't get data.
Actually, sir, if we see means the battery has different battery lithium, and battery has different chemical composition, and that limit the current value. That means for in this case the voltage is from 2.5 to, wait a minute, I will show. Here the voltage is maximum nominal voltage 3.3, that is from 2.5 to 4 voltage we can. So there is a limitation of minimum and the maximum. We cannot increase more than.
Okay. Nice. So ultimately, you found that only rainforest model is only giving you the best result.
Yes, sir. Actually, we are not getting the time series analysis. So right now we only say that the random forest give the best result.
Okay, from my side, okay. Or I mean, I'll look into your report and other things.
Yes.
Yeah, that's it also from my side.
Okay.
So thank you.
Okay. Thank you, sir.
I don't
Thank-
see. I think other group is here. Any other group member is here? So I don't know, sir. What should we do? I mean, I think we should mark them absent, and they will not be eligible for the certificate because I mean, there is no update why people are not here and all. It's okay. So no problem. So then tomorrow we have two more groups, sir. Tomorrow we have two groups. I hope they will be there. Because out of that one is actively doing. I think Rajni, you are also there in tomorrow's group.
Yes, sir. Yes, sir. We are four members in that group. So we divided equally divided our work also, and we will present accordingly, sir.
Yes, yes.
So Rajini works with both group, correct?
Yes, sir. Yes, sir. Actually, initially I started with the Meena and group, and then Abhishek also came to me and he's told that we will do the one project also. So idea for electrical vehicle was from my side only because I was working in electrical vehicle itself. So we both created one group for another project.
I mean, I could see only this presentation by Abhishek and Mr. Rajnikant. Is there any other person who presented this here?
Sir, no. Today in their group there is one more person, Mr. Keshav Gupta, but according to them, there is almost zero contribution from Keshav
Okay.
Gupta, and he is also not present today. So we can
Okay.
mark him absent also.
Okay.
I will mark him absent.
Okay. So for other presentation, I think this all the people should be present, and if they want
Yes,
to
yes,
get
they
this
should be. This is the
credit.
information we have circulated that everyone should be present because last time we have told. I'll again post in the group for tomorrow also. Everyone should be present. Okay,
Right.
from each group, everyone should be present. Otherwise, they will be marked absent. Okay.
Okay.
Until unless they can inform prior, but they should be there for the final presentation. There's no excuse.
Okay.
Okay. So thank you, sir. Thank you, Abhishek.
Thank you, yeah, Himanshu.
Thank
Thank
you.
you, sir.
Okay. Thank you, sir. Thank you.
Good night,
Okay,
sir.
okay, bye. Bye, good night all.
Good night.
Good night, sir.
Bye.